Here's a short video on the rules of differentiation. The general form is y equals x to the n, and if y equals x to the n, then the derivative dy dx is nx to the n minus 1. So if we have a function y equals x to the 7, then here n equals 7, hence dy dx equals 7x to the 6, because n minus 1 is 7 minus 1. Let's look at another example. Here we have two functions, y equals x cubed plus x to the 6. When we differentiate them, we still differentiate them as though they were separate functions. In other words, x cubed becomes 3x squared, and x to the 6 becomes 6x to the 5, using the rule in the top right hand corner. Let's look at a trickier one. Here we have the function y equals 1 over x squared. Notice the x squared is on the bottom of the fraction, and this is quite difficult to do at this stage, so we now put x squared up on the top. In other words, we remove the denominator and express it as x to the minus 2. Now we have a negative index, and when we differentiate that, n is now negative 2. So the derivative dy dx is negative 2x to the negative 3, because n minus 1 is minus 2 minus 1. Notice we finally revert back to the fraction, because x to the minus 3 is minus 2 over x cubed. Let's look at this function, y equals the square root of x. We express y equals the square root of x as an index, so we write it as x to the half. And we always do this before we differentiate. Now, proceeding with the differentiation, dy dx will be a half x to the minus a half, because here n is a half, so n minus 1 is a half minus 1, which is minus a half. So our final answer is 1 over 2 to the square root of x. Now let's look at a more complicated fraction. The function here is now x to the 4 minus 1 all over the square root of x. Here I'm breaking it up into two separate fractions. In other words, it's x to the 4 over x to the half minus 1 over x to the half. Notice I've replaced the square root sign by an index. And now I write x to the 4 over x to the half as one term, which is x to the 7 over 2. 1 over x to the half is the same as x to the minus a half. In other words, I'm dividing through by x to the half. The derivative is now calculated separately, because we have two functions here to differentiate. So x to the 7 over 2 becomes 7 over 2 x to the 5 over 2, and x to the minus a half becomes a half x to the minus 3 over 2. Notice we have two negative signs, one before the negative x, and the index is negative a half, so the two negatives give us a positive as our answer, so that we have the answer. What about a derivative of a function which has a constant in front of it? K is the constant. If we have a constant in front of the function, then the derivative is the constant multiplied by the rule that we've used before, nx to the n minus 1. Let's look at an example. The function here is y equals 7x to the 6. So the derivative dy dx is 7. We leave the constant alone, and now we just differentiate x to the 6, which becomes 6x to the 5. The final answer is given by 7 times 6 x to the 5. 7 6 is 42, so the answer is now 42 x to the 5. Finally, the derivative of a function which is simply a constant. So here, if y equals a constant, then the derivative is always 0. Probably the easiest one of the lot to remember. In other words, if you have any number which is a constant, such as 99, y equals 99, then the derivative is equal to 0. Now try some questions for yourself. Here are 10 questions that I want you to differentiate. The answers are on the next slide. Thanks for watching this video.